Hello students, let's understand about the motions of the earth in this lecture. Every day we observe the sun rising in the east and with it starts the day. At noon it is at its highest position in the sky and thereafter it starts declining to set in the west in the evening. This daily movement of the sun's path across the sky makes us imagine that the earth is stationary and the sun is moving round the earth. But in fact, the position is just the reverse. The Earth, like all other planets in the solar system, revolves around the Sun in an elliptical orbit and it also rotates on its axis. These two motions of the Earth are known as revolution and rotation, respectively. Many phenomena on Earth, like day and night, seasons, winds, and ocean currents, depend on these motions. Rotation is the spinning of the earth on its axis from west to east once in 24 hours. The axis is the imaginary line passing through the center of the earth as it does on the globe. The two endpoints through which the axis passes are known as the North Pole and the South Pole. The earth is always tilted in the same direction as it moves around the sun. The angle at which the earth is tilted, that is known as the inclination of the earth's axis. The earth completes one rotation from west to east on its axis in 23 hours and 56 minutes and 4.9 seconds, means roughly in 24 hours. Speed is one of the most important characteristics of the rotation of the earth, that is maximum at the equator and it decreases towards the pole. Now why is it? Because the answer is the Coriolis effect which lies in Earth's rotation. That I'll explain you in the next slide. Specifically, Earth rotates faster at the equator than it does at the poles. Earth is wider at the equator. So, to make a rotation in one 24-hour period, equatorial regions race nearly 1600 kilometers per hour. Now these are the effects of rotation of the earth, that how the rotation of the earth causes day and night, sunrise and sunset, how it creates the variation in the length of the days, then how Coriolis effect works, how the movement of the sun and moon from east to west take place when we are seeing from the surface of the earth, then how the equatorial bulge is created, what is the variation of temperature between day and night, how, then how the difference in time has been created by the rotation of the earth. The rotation of the earth causes the formation of the day and night. Earth is an opaque body. It receives its light and heat from the sun. When the earth rotates on its axis, one half of it facing the sun is in light. The other half remains in darkness. Thus, each part of the earth's surface comes into the sunlight for a certain period and then turns away from it in 24 hours. The lighted part of the earth has day and the other half in darkness has night. This is how the days and nights are formed. Imagine what will happen if the earth stops rotating on its axis. In fact, it is because of the rotation of the earth that day and night follows each other in regular succession in all parts of the earth. The next effect of the rotation of the earth, that is sunrise and sunset. Now, every part of the earth's surface faces the sun at some time or the other. The part of the earth that moves from darkness into the sun's rays experiences sunrise, and when it moves away from the sun rays, it experiences sunset. Now, let's understand about the Coriolis effect, which refers to the force explained by any object moving over the surface of the rotating body such as the earth. The Coriolis effect plays an important role in the movement of air, that is wind, and water, that is ocean current, on the earth. Due to its effect, the winds and ocean currents move clockwise and are deflected to the right in the northern hemisphere and move in the anticlockwise direction and are deflected to the left in the southern hemisphere. This is the best example to understand how does the Coriolis effect works. Also, I would like to show you one small video to understand the Coriolis effect. Now, one more effect of the rotation is that when we are standing at the surface of the earth and we look up in the sky, we find that the planets, the stars, moon, and the sun, all they appear to move from east to west. But then how does it happen? Whereas earth moves from west to east. Now, this effect is similar to what one experiences while looking at the trees or the poles or lights from a moving train. The sun, the moon, the planets, and the stars, they all rise in the east and set in the west. It's because Earth spins towards the east. Earth rotates or spins towards the east, and that's why the sun, moon, planets, and stars, they all rise in the east and make their way westward across the sky. Now, the speed of the rotation, it also creates a centrifugal force and which results the bulge in the middle portion, that is equatorial portion of the earth, and flattened up at the poles. So that is the reason the earth looks like a sphere, flattened at the poles and the equatorial middle part, that is bulged out. Now, if you just want to experience that, how does it happen? How the middle part of the sphere gets bulged out and flattened at the poles or at the top. So you can take a bangle and you just move it in a faster speed, or you can conduct this activity at home. Yes, one more effect, that rotation causes a difference in time over various places on the earth. And we have learned in the previous chapter, that is longitude and time zone. So the difference in time is 4 minutes for each degree of longitude, means 24 hours, that is divided by 360. Now, how is it? Why does it happen? See, our earth rotates on its own axis. Due to this rotation, different parts of the earth receive different amounts of sunlight, thus causing morning, noon, evening, and night. Now, if we had one time zone, then 12 p.m. would be noon at some places, but then it would be night or evening at other places, which would be inconvenient. Now, this is also one of the most important effect of the rotation of the earth, that is variation between day and night. Now, what happens? The side of the earth towards the sun constantly gains heat, and the side which is away from the sun constantly loses heat by radiating it into outer space. In this respect, rotation of the earth in a tilted position on its axis has the best advantage, and that the short rotational period makes the variation of temperature between day and night moderate. Earth's rotation also affects the tides. During low high tides, the earth itself is pulled slightly towards the moon, creating high tides on the opposite side of the planet. Earth's rotation and the gravitational pull of the sun and moon create tides on our planet. As the ocean bulges towards the moon, a high tide is created. If you see this image, you will understand how the Earth's rotation causes tides. The Earth's rotation and the gravitational pull of the sun and moon create tides. because the moon is much closer to Earth than the sun. The moon exerts a much stronger gravitational pull. The Earth's oceans respond to the moon's gravitational pull by bulging and dipping as the moon revolves around the Earth. So here we will understand how again that the rotation of the Earth also affects the wind speed and direction. Wind which comes on the surface of the Earth from all directions, and as the Earth rotates on its axis, so different places suddenly gets a big jerk, or you can say surge of wind, due to this rotation of the Earth. So here we understood that how the rotation of the Earth causes the wind speed and the direction. I would like to show you a small video regarding the spinning of the Earth.
Sitting by our window, we watch as the days and nights roll by, bringing with it the snow of winter, the warmth of summer, the freshness of monsoon, the scent of spring, and the coziness of autumn. Have we ever paused to wonder how these wonderful changes that we witness occur? And when we do, what is unveiled is nothing short of a miracle in process. Like the human body, the climatic conditions of Earth also undergo yearly physical changes in a repetitive manner called seasonal changes, which is a division of the year marked by changes in weather, ecology, and hours of daylight. But how and why do seasons change? Although the reason for the existence of seasons may not be as dramatic as ancient Greek mythological symbolism of an unfortunate marriage between Persephone and Hades, it is nonetheless quite interesting. You see, the Earth rotates on an axis, tilting and spinning quite like a top. Simultaneously, it revolves around the Sun in an elliptical or oval orbit, taking one long year comprising of 365 days to make one huge round. Due to the orbit's elliptical nature and the Earth's tilting disposition, some parts at certain periods on Earth are exposed to the sun's rays and heat more directly than the others. The root cause of this phenomena is the axis, an imaginary line that divides the Earth into two poles, North Pole and South Pole, splitting the planet in the middle. The Earth's axis is tilted from perpendicular to the elliptical plane by 23.45 degrees. This tilting is what gives us the 4 seasons of the year, namely the spring, the summer, the autumn or fall, and the winter. Since the axis is tilted, different parts of the globe are oriented towards the sun at different times of the year, which is determined by the relationship between the overhead sun and the Earth.
So I hope you must have understood that what is the rotation called and what are the effects of the rotation of the Earth. So here one question for you as homework. So I want that you think over and write down your answers in your notebook and please send me on my WhatsApp account. So let's discuss about the part 2, that is revolution, in the next lecture. Till then, thank you and have a nice day ahead.